This podcast is going to review how we determine how many electrons will fit in the electron configuration in the electron cloud. The first thing I want to review is where we get the proton number. The number of protons equals the atomic number found in the periodic table. And when we're considering atoms, we want them to be electrically neutral. So the number of protons will equal the number of electrons if an atom is to be electrically neutral. So the number of protons will equal the number of electrons to be electrically neutral. For example, let's look at hydrogen. Hydrogen has one proton, which is positive, and it would have one electron. Electrons are negative, so that there would be a zero charge for that atom. That would be the same for all of the atoms. So take, for instance, aluminum. Aluminum would have 13 protons from the atomic number, and to be electrically neutral, it would have 13 electrons. The textbook uses this graphic to show the electron configuration of the electron cloud. In the center, we see the nucleus with the floor. And then there's layers of electrons in each of the levels. Increasing energy is required to reach the outer shell of the electron cloud. As you will see, the first energy level can hold 2 electrons. The second energy level will hold 8 electrons. The third step will hold 18, and the fourth 32. Your textbook doesn't go into great detail on how the electrons are assigned to each of the energy levels. It's an advanced topic that you'll learn in chemistry because those different numbers of electrons per energy level are caused by something called orbitals. For our purposes in the class, we're just going to show you some of the basics and try to figure out where the electrons will be found in the energy levels. To help us, we're going to modify the periodic table. We're going to move helium over to the spot right next to hydrogen, just like so, through cutting and pasting. And we're going to examine where the electrons would be found. In class, we use this energy map to help figure out where we would put each of our electrons. Right? As we know, going from one energy level to another, we need increasing amounts of energy. So we'll show you how we use that in class. First, let's look at the simplest possible atom. Let's draw hydrogen. Hydrogen has one proton. So it would have, to be electrically neutral, one electron. On the map, we would have only one electron of the 2 possible filled in the first energy level. That's indicative on our periodic table. As we described in class, each row represents one of the energy levels. The first energy level can only hold 2 for hydrogen, and then if you were to fill both of them, helium. Helium has 2 protons. Thus, to be electrically neutral, it must have 2 electrons. By using the map, we see that we have the full first energy level, and we can draw helium just like so. If we take another element, let's say lithium, and look at how we would draw lithium, we notice that lithium is here in the second row, right, or second period. Go to the electron map, cover the first 3 electrons because lithium would have 3 protons, and we find out that it has 2 energy levels. One electron here and one and only one in its second layer. We see that because it is in the first column of the first period. Now let's look at neon, one of the noble gases. Right off the bat, we should notice that neon is in the last column, or last group, with the noble gases in the second period, or row. We know that means that neon is going to have 2 energy levels. Knowing that neon has 10 protons, we can rearrange our electrons. We have 2 in the first energy level, and then in our second energy level, we have a total of 8. Which makes sense because it's in the noble gases, and we know that the energy level for a noble gas should be filled. There are no empty spaces in our electron level, the second level for our needle. Let's do one last one. Let's do sodium. Sodium is in the third row, which tells us that it has 3 energy levels. We also know that sodium has only 1 electron in its third level because it's in the first group of the element. We know that the first level can hold 2, and that the second level can hold 8. We know that they're all filled because of sodium's position on the periodic table. And we can verify that by looking at our electron map. We need a total of 11 electrons. 1, 2. And we have verified that we can use the periodic table. Now remember, our electron map only works for elements through calcium. We cannot do any larger elements from beyond calcium into the various metals. Okay, this is the end of this podcast.